Alright, 5.3 is the liquid state. So we talked about gases and specifically ideal gas. Um, Now, it's a liquid state, pretty simple, very short section. Um, so, you have a solid. To make it a liquid, you have to heat it. And, um, and the opposite is cooling it to turn back into a solid, or what, aka freezing. So to melt, you have to have energy transferred to the solid, moving the particles more vigorously. Then the attractive forces actually become weaker, and you got a liquid. Freezing is the opposite. It loses kinetic energy, um, and then the force of attraction strengthens, and they stop sliding past each other than when temperature is low enough. So liquids, they basically are moving past each other as they become less kinetic energy. Then they have attractive forces, and then they won't slide past each other as much until they freeze. Now, if you want to turn into a gas, you gotta continue heating into turn into a vapor, and again cooling back down into from a gas to a liquid, from a vapor to a liquid by cooling. So vaporization, again, you need more energy to transfer the liquid to a vapor, which means the particles are moving faster. Again, the forces are continuing to become weakened. That's why gases or vapors can escape with more energy. When liquid evaporates, that is before boiling point. So even though temperatures haven't reached their boiling point, you do have liquids evaporating, such as water. The particles become more free when the forces are weakened. They move faster because there's more energy, there's more spread out, and then you reach the boiling point, and now you have vapor. Alright, the enthalpy of vaporization, energy is needed to change 1 mole liquid to 1 mole of gas. So from water to 100 degrees Celsius, you go to steam, 100 degrees Celsius, that is the heat of vaporization. It's basically joules per mole. Condensing is the cooling of vapor. So going back from a vapor to a liquid, it loses kinetic energy to the environment. Molecules again start moving slower because there's less energy. Attractive forces become stronger, and they move closer together, and you have liquefied vapor. So you can see in this image, you have a very weak, strong attractionness in the A, with very little vapor escaping. Then increase energy, you have more of the more of the liquid molecules escaping into vapor. And then C, you even have more vapor occurring because there's a higher temperature, more energy to create the movement of liquid to vapor. Alright, equilibrium. So how do you reach equilibrium? Basically, you have enough kinetic energy that the vapor is condensing at the same rate as the liquid is turning into vapor. In the early stage, you have liquid escaping into vapor and very little vapor into liquid. You become, as time moves on, the liquid is still escaping, but you have some more vapor condensing back into liquid. And then once you're in equilibrium, that means you have a saturated vapor. That means no more vapor can escape. And then you have equal parts of the liquid turning into vapor, and then the vapor coming back into a liquid. So going back and forth at equilibrium. Vapor pressure, this is the pressure exerted by a vapor at equilibrium. As temperature increases, vapor pressure increases. That means you have more vapor. That makes sense because molecules are moving faster, so more are going to turn into a vapor. That means you need more kinetic energy. Moving faster overcomes the intermolecular forces of attraction, and you have your vapor. The boiling point is defined as when the vapor pressure is equal to the atmospheric pressure. So at room temperature, our pressure atmosphere is around 760 atm. I'm sorry, 760 millimeters of mercury, 1 atm. When water reaches 100 degrees Celsius, the vapor pressure, the pressure of your liquid, now reaches 1 atmosphere, so you have gases to escape. So basically, think about the pressure from the atmosphere is pushing down on the liquid, and the liquid has to overcome that pressure. Once they're equal, then you have boilage. So there's a difference between evaporation and equilibrium. Evaporation is just the escape out to the atmosphere. In equilibrium, you have to have a container, and you have molecules moving into liquid and molecules moving into vapor at the same time, and you reach saturation, and no more will escape out. No more will turn into vapor. The end. No homework questions on 5.3.